Hey, good morning. We are going to continue with Chapter 10 today, classes. I do have a poll up just for fun, so I'll leave it up for a minute. See if anybody...
I had a quick question, Dr. Carlson.
Sure, shoot.
Is there a reason why you're in red today and not blue?
It's the Sith color? Yeah, it's because it's Halloween. Is it too scary? Do you want me to... I mean, I can go back to blue.
It's fine. I was just curious. I was like, oh, you changed colors today.
All right, worst Halloween candy. In a minute, I'm surprised nobody's picked off-brand candy. That's one of the worst. Strong dislike for a baggie of grapes. That's a little bit of a surprise, the healthy option. As a brief recap, Chapter 10 is about creating your own classes. So we said it's a shift in thinking because all of our programming so far, although it's used on a lot of classes, we've used the built-in Java classes. You can't even write a simple hello world app without writing a class and without then creating an object when you run it. So the shift is to create objects that support the app that we're trying to write. So in a business scenario, it could be things like a customer, an order, a food item, and so on and so forth. When you look at trying to build an app using an object-oriented language, that's the shift, is to think about what are the objects that I'm going to need to create and manage to facilitate the app that I'm. All right, so I'm gonna end the poll, and the loose Baby Ruth without the wrapper is the winner. And then the handful of Flintstones with no dinos, obviously, is also an equally bad choice almost. All right, I thought the coupon for the 2-for-1 bowling shoe would win out, but I guess we've got some bowlers. All right, let's get started. We stopped here at Pirate Customer Report. We're looking at this membership level analysis. It is very similar to the one we had last week. I did change to from doubloons to points, and these are now doubles. And the loyalty club for our awful pizzeria is the booty club, so you get booty points. Booty because pirates like their boots. So the report is the same as last time for all intents and purposes, except for that one difference, but it is generating random point club balances, and then based on those point club balances, assigning a given pirate to a membership level, and every time you hit the run report button, it generates a new report with random point club balances and doing the assignments. Obviously, the thing that's different is under the hood. So instead of two separate arrays, an array with the pirate names and then a separate array with, say, their point club balances, to get this to work in a more object-oriented fashion, we're going to create a Pirate Customer Class, and then each of these pirates will be Pirate Customer objects, and they will have a name and a point club balance assigned to them so that each object encapsulates everything it needs to describe pirate customers, and then we'll have one and only one array of pirate customer objects. We won't have to worry about whether our data is synced between multiple arrays because there won't be multiple arrays. It looks virtually the same as what we had last week. Every time you press the button, you get new numbers. Membership levels are assigned based on the numbers, and then the average is calculated. The only difference, again, is that I've switched from an integer point club balance system to a double one. So how do we do that? Last time we did the simple customer class, and this is kind of just a small step, I think, past that. This is just the Keynote has descriptions of the app and how the membership loyalty club works, but we talked about that last week, so I'm going to skip ahead to a simple Pirate Customer Class as a starting point. So, and again, it is kind of like you guys have all either had the database class or are taking the database class, and this is a bit like, more than a bit like, thinking about what a table of pirates, pirate records would look like. What is the data that we need to manage for our pirate customers, and what are the data types? So just as an initial look at this issue of what a pirate customer might need, we obviously have a name, which is text or string data. We've got this loyalty club point balance, which I switched to doubles. And then the pirate customer needs a membership level. So we'll start out just describing that as a string because, it is just a text string like gold, bronze, silver, dirt, whatever it is. The only thing to think about is, do you want membership level, to be stored, or it really is the result of a calculation. It's the result of evaluating the point club balance and then assigning a membership level based on that evaluation. So actually the way I've implemented it is PirateCustomer does not have a membership level attribute. Rather, it's got a method, getMembershipLevel, which does the evaluation and returns the string membership level to the calling line of code for the production of the report. All right. So this is actually what it looks like. This is in the download for the chapter. If you've already opened it up, this is what it looks like. There's two attributes, name string and the double booty points. There's a constructor. The constructor takes two parameters, the name and the balance. And then all it does is round the balance to 2 decimal places. So I'm using, you might recognize that as essentially the bad money round approach, which I've told you not to use for money. But this is not money anymore. It's just points. So this is a perfectly good way to round just a generic double value to some number of decimal places. In the app, if you look at it, I also have the bad money round method that I use. But again, I don't use it to round money, so bad money round's fine for not rounding money. If you want to round money, again, you want to use that number format class and get a currency instance, and then use the format method built into the number format object to do your rounding and formatting. At least until we get to chapter 15, where we'll learn an additional way to do it. And then the getMembershipLevel method, again, as promised, just does the evaluation of the loyalty club points based on a sequence of if tests, assigns either like dirt, less than bronze, silver, or gold as the membership level. All right, so we're going to switch at some point to Eclipse and do this and play around with this, but I want to cover the mechanics of what we're doing, in detail, a little bit more detail first, so that you guys have a sense of what you're going to be looking at. So the PirateCustomer class would be used to create PirateCustomer objects. To create PirateCustomer objects, we'd use the new instantiation syntax, just as we would to create objects of any class type. We're going to create an array of Pirate customers. So the class is PirateCustomer, capital P, capital C. So if we want to create an array of that type, the syntax is this first line of code, PirateCustomer, and then open and close square brackets, the name of the array, which I called pirates, the assignment operator, the new keyword. So we're instantiating an array of pirate customer objects sized at 6 pirate customers. So that's just the standard array creation syntax. And again, it is weird. There's no question. It's weird. You have 2 sets of square brackets. Only one set has a number in it. It uses the keyword new, but then doesn't use parentheses. Here, where you would expect it to use parentheses, it uses the second set of square brackets. And then the number given creates an array with 6 data elements in it, 6 cells in it, however you want to say. That's a list of up to 6 items. They'll get the integer index numbers 0 to 5 because Java starts numbering indexes at 0. So we'll use the index number 0 to 5 to work with the array of pirate customer objects. If you want to create a new pirate customer object and add it to the array, then that's the second line of code here. So if we put a new pirate customer into the first index of our array, it would be pirates index 0 equals new pirate customer. And then the pirate customers need 2 pieces of data. One is the name of the pirate. So this is Captain Kidd. And then the second parameter we're passing to it is the point club balance. And again, this would be something that you would look up, in a database maybe, or read in some manner into your app. But in these examples, I'm just generating a random number of loyalty club points, up to 40, roughly, points. And why is that? Why does it need those 2? It's because of the constructor. This is how the constructor is written, is that to create a new pirate customer, I need a string and a double passed. If you try to create a pirate customer without passing it what is requested in the constructor, you're going to get a compiler error. All right. So the report itself uses the same exact technique that we used last week, in that there's a text area added to a scroll pane, which gives us a scrollable text area. On screen, it's in the center region. South region is the button that generates the report. The syntax now for generating each line of that report, though, describing each of the pirate customers, is a little bit different, because we now don't have two arrays that we have to reach into. We just reach into the one array, which is called pirates. We still need an index number to work with it if we want to go through index number 0 to index number 5. That's 6, so we're stopping at 1 less than 6. So we'll go 0 to 5. We're going to build up each pirate customer using string concatenation, just like we did last time, but to get the pirate's name, the syntax is now array pirates index j and then the dot attribute. So we can reach into the pirates array and use that same object.attribute syntax that we're used to, because pirates j is a pirate customer. Likewise, to get to the loyalty club points, it is pirates j dot bootyPoints for the attribute. We're still using tabs to format to try to get our text output to align in columns. Tab symbol is \T. We use it in a few places here. And then to get the membership level, we call the getMembershipLevel method on pirates j. So for each pirate, 0 to 5, we should get a report with their name, their loyalty club points, and their associated membership level. And that's how we'd build it up using string concatenation. All right, so let's pause here and switch to Eclipse and have a look at the report in a little bit more detail. In this example, I put the pirate customer in its own class. And just to organize my own chapter 10 work, I've got multiple packages for the various examples, and pirate customer report is in its own package. So we have the package declaration up at the top to make that work. Otherwise, it's identical to what is in the keynote that you just saw. So we've got the two attributes, name string and bootyPoints, the double. We've got the constructor requiring the two parameters passed to it. In the constructor, we assign the name and we round the point club balance to 2 decimal places, because obviously when we generate a random double, we could get a long tail of decimals that we don't want. And then there's the getMembershipLevel method starting on line 15. And so to kind of recall back to chapter 9 and writing methods, the string is the return value, so getMembershipLevel has to do something which results in a string being returned. And so really all getMembershipLevel is a sequence of if-else-if statements, each one with its own return value. So there's a return in each possible outcome of the if statement, which meets the requirement that no matter what happens, when the app runs, it will return a string of some value. getMembershipLevel does not take a parameter. And so you might wonder why didn't I pass that double number to it? Why didn't I pass the bootyPoints number to use? And the answer is, well, I don't need to, because the loyalty club balance there on line 6 is an instance variable, and it's visible therefore throughout this class, so it is in scope. So the number I need to use to get membership level to work is already accessible, it's already visible, it's already in scope. There's no need to pass it, that value, because I can directly access it inside the body of getMembershipLevel. So that was one of the rules or guidelines when trying to think through, do I pass a value or do I not pass a value to a method, is the value that you need, is it already in scope? If it's in scope, you don't need to pass it. Could you pass it? Yeah, you could rewrite that to pass it. It would just add another level of complexity that doesn't do anything. All right, let me zoom in here just to show you the little pieces. Again, this is very, very, very similar to the report we looked at last week. So it's got the exact same UI setup. The differences are here in that we have one and only one array called pirates, and it is an array of pirate customer objects. Everything else, the main method is identical, the UI setup is identical. I do call a method called getCustomerData just to organize it into a place. So getCustomerData just fills up the array. And I've hard-coded in 6 pirate customers: Captain Kidd, Mr. Beard, Captain She, Miss Bonnie, Sir Morgan, Colonel Cy. I give them each a random loyalty club balance, except I want 1 0, so I hard-coded Sir Morgan in as a 0. Otherwise, the report still uses these many different methods because remember it was initially an example of writing code with lots of methods in it. So there's still lots of methods. They're the same methods. When the button is pressed, then the action perform is executed. I call getCustomerData as the first step, which is that new method I just showed you up here, which fills up the array with random point balances except for the 1, 0. I clear the text area, and then I build the report up. This is exactly the same code we had last week, except for this line, which is split between 102 and 103, which builds up the string using string concatenation, but is simpler and easier to read, because now you read it as piratesj.name. Well, you know that's the name. In the example from last week, it was namesj or something. This tells you really clearly you're pulling out a pirate from an array and you're accessing their name, and then you're accessing their loyalty club points, and then you're accessing a method which will give you their membership level. So in lots of ways, as I keep saying, it's just one array. I don't have to worry about syncing multiple arrays. And then just from a readability standpoint, if you create your array with a name that makes sense, and all of your attributes with names that make sense, identifiers that make sense, and your method with a name that makes sense, then reading a line of code like this becomes pretty descriptive of what you should actually see on screen. Just to run it again, this generates the membership level analysis with random points, except for Sir Morgan, who is like dirt but without use no matter what happens. Every time you hit the button, you get a new report, a different average, obviously every time. What makes this work is this class. So we've looked at the situation, this report that we need to generate, and it's a simple report. It's describing our pirate customers, those who frequent our awful pirate pizzeria. And so all we need to do is think through what data do we need to store and manage about our pirate customers, and that's what needs to be described in this class. And then when our app runs, it creates pirate customer objects for us to work with, which is done here. All right. Normally, if it was a face-to-face semester, I'd stop and break you guys into your teams and have you do a quick activity. I thought maybe we would just code something like it together. Sometimes typing it in and getting something to run is, more educational than just watching something that I've already coded and watching it run, because you would expect that it'll work fine because I already coded and tested it. I'm going to switch workspaces so that I'm in the workspace for 2020. All right, so we're in chapter 10. Okay, so we'll do, I need a new Java class. Just call it activity 1. I'm going to call it an app explicitly, just to, I want to make sure that you're not getting confused about where does the main method go, because it does trip people up. So the app is what is executable. The app is what Java runs to produce, say, your report, and it will need a main method. So I'm just adding app to the end of this to remind you that activity 1 is an app. It does need a main method, and it is the only part that needs a main method, no matter how many other classes we decide we need, and we will get more and more as we build up towards a point of sale which supports our pirate restaurant. But again, even when we get there, there will only be one main method, and it'll be in the point of sale app or POS app. If you've read ahead, you'll know we generate multiple variations of these, and they're numbered, and we go from POS 0 to 7 or 8. And there are different versions that emphasize different things that we're learning in the different chapters. So for instance, if you want to learn about printing reports, there's a chapter on printing, and it's got its own variation of the point of sale, which focuses on how to print receipts and reports and stuff. All right, so just to keep this simple, I'm going to make it a console-based app, so I won't extend JFrame. There won't be any event handling. It will just be this very basic structure. And then we need a class that would describe teammates. So you could call it whatever you wanted, but you need the keyword class, and then you need the name of the class, and then an open and close parenthesis. The style suggested by Sun and by Oracle is to capitalize class names so that when you're reading through your code and you're writing a line of code, you can easily distinguish between classes and objects. And partly that's because there's a certainly a good proportion of Java developers who like to create objects with the same name as the class, but differentiated by starting with a lowercase letter. What I figured out earlier this semester is it makes it tough to describe a line of code when you're saying something like teammate equals new teammate. That's just a confusing thing to say. In any case, I would still recommend capitalizing class names and starting object names with lower names. So that's a valid class. This is actually a valid app. It would run, it wouldn't do anything, produces no output whatsoever, and the teammate class is empty and isn't used. So although I've paused at a spot that does compile and would work, it doesn't do anything, and there's no point testing it at this point. So teammates, I think I said it needed a name, a major, and I said a GPA or some other number. So just to think through with the data types and the names, it would look something like this. I'm using the $signs here just to emphasize that these are strings. Again, that's not a requirement. I did not initialize those attributes. As a result, I need a constructor that will do that. So the constructor will be given the same name as the class, so it's teammate. And again, just as a reminder, constructors violate the rules of method building that we covered last week. In any case, to make this work, we need to pass the teammate constructor the 3 pieces of data that are needed to initialize a new teammate object. So it needs to get a string. I'm going to call them N, M, and then a double GPA lowercase. So whatever you name your parameters is entirely up to you. You might have noticed when Eclipse writes the method for you, it uses the actual names of the attributes, which you can do. The issue, let me do it this way and then I'll show you what the issue is if you were to do that. These constructors are super easy. I'm not going to do any data validation, so it's just name string equals N major string equals M, and then GPA equals GPA. Well, and it's that third line that might even give you a clue towards why this can be confusing. Java's case sensitive, so the line on line 20, capitals, all caps GPA equals all lowercase GPA works because I'm assigning the parameter passed, which is lowercase GPA, into the attribute uppercase GPA. You can call these 3 parameters anything. You could call them param1, param2, param3. And in some ways that would be equally good in terms of writing out the constructor and keeping it straight in your head what you're doing. Eclipse by default names them the exact same thing. So in Eclipse, if you had it create a method for you, you would get something much more like this, which would end up saying something like namestrings equals namestrings, which is then super confusing because the parameters has the same name as the attribute. And so you have to specify that you mean the name string that's associated with this class. So you use the keyword this to clarify that what you're doing is assigning the parameter name strings to the attribute name strings. But it makes for this line of code on line 18 that can be a little bit confusing. It does work. The one advantage is in Eclipse or in the IDE when you're calling teammate the constructor, it'll give you this parameter as part of the suggestion of what you're filling in. Because it's easy to get confused, right? Later when you're using your customer objects, you might wonder, well, I know I need 2 strings, but was it the major first and then their name? Or was it the name and then the major? I don't remember. So if you give descriptive parameter names here, it can be helpful in terms of cluing you into when you're using, creating objects of that type later. I'm going to stick, though, just to N, which doesn't create that weirdness, and then also means you don't need the keyword this. You can use it if you want to. I don't know if you figured it out, but if you really hate typing, you can type this dot and then select what you want out of the class attributes. I don't know that it ends up being shorter here, but if you have a class with lots of methods and long method names and maybe some weird capitalizations, decisions you had to make based on the names, then sometimes it's easier, instead of trying to remember what you typed exactly, to use this dot and then look for it and then pick the correct method instead of trying to type it from memory. All right, so that's a valid class with a constructor and 3 attributes. What we need to do now is create some teammate objects. So we could do that in the constructor. So let's just create 3 teammate objects maybe. So I'm going to create an array to hold them. So the syntax to do the array is class type for the array, the data type for the array, which is teammate, empty square braces, equals new, class name again, and then a size. I forgot to name, sorry, skipped right over the name. So we'll call this, I don't know, team. So a complete syntax to create an array called team of teammate objects with room for 3 teammates is teammate, empty square braces, valid identifier equals new, class name teammate, and then the size. This is also can be confusing to beginners because it looks like you've just created on line 4, I'm looking at line 4 here, it looks like you've just created an array with 3 teammates in it. And you have not. You've created an empty array ready to hold up to 3 teammates. But just based on line 4, it is empty. It doesn't contain anything. And it's tricky because you look at it and you think, well, it uses this keyword new. I know that creates new stuff. It looks like it's creating 3 new teammates. But it's not. It's reserving slots in memory to hold 3 teammate objects in this array. But you haven't fed it the data, you haven't fed it the teammate objects to fill it up. So we need to do that. And the syntax will be array name and then index. So I'll start with team 0. And then I'm going to say new teammate. Oh, I got to get the capitalization correct. And then I need to pass it the 3 parameters. So we'll say, I don't know, Joby, major, obviously MIS, GPA is some double number, so we could just simulate 4 times math.random. That'll give us a double number that is like it could be quite poor actually, but and then team table slot 1 goes to some other student, maybe accounting, and same thing, 4 times.
Your teammate needs to be capitalized right now.
Oh, yes it does. Thank you. I will get right back to that. All right, and then the last one. Well, in honor of Aaron, we'll say Aaron, obviously MIS, and we'll just say, how about we just say 4? Give him a decent GPA. Okay, so that does create 3 teammate objects and calls the teammate constructor and passes the 3 parameters required. Whatever I declare the constructor to need down on line 23 is what I must pass it. That said, if I had scenarios in which I might want to create default teammates and not pass it data, I could create a default constructor that took no parameters, if that made sense. So I could overload, the term is in Java, I could overload the constructor to create multiple variations that met my needs. I don't have that need for this app, so I haven't done it. So this creates data. What we want to do now is produce a report on the teammates. So if I wanted to loop through it, the first question is, okay, well, which loop do I use? Java's got the 3 loops we learned about a few chapters ago, but looping through arrays is such a common thing that we need to do, and typically the best loop to do that is the for loop. It's the best because we know how to write out every part of the for loop's requirements. It needs the index, it needs the stopping spot, and it needs the counting rule. It creates an index variable, and normally when working through arrays, we need an index variable to talk to each of the cells in the array, essentially to access each of the cells in the array. So the for loop, 99% of the time, will be what you want to use. I'm going to say for integer j starting at 0, right, 0, j less than team.length, and then j++. That gives me a loop that will move through the entirety of the array. I use team.length instead of the number 3, just in case later I want to add more teammates. If I resize the array, if the team gets bigger, it won't break my for loop. So I want to write as much code as I can that won't get broken when I modify stuff that I'm likely to modify. Okay, so build up that string. If you're following along or even trying to get ahead of me, hopefully you've already started this, we're going to use the tab character to try to line this up. I'm just going to write it out to the console, so I'll say system out print line. Well, here I'll write a header as well. So it's going to say name /t and then major /t and then GPA. I don't need a /t on the end of that. And then in terms of building up the string that describes each teammate, we're going to access their name. So the syntax will be team j dot name. String concatenation to add on the tab character. String concatenation to add on the major. So team j dot major. And then string concatenation to add on a tab concatenation to add on the GPA, which would be team j dot GPA. So unless I have a typo in there somewhere, which obviously does happen, you guys have seen it, this should give me a little output dumped out to the console, formatted nicely, which gives me the data that I've stored in the array. But let's see. So yeah, that's what we've got. Almost always with these sorts of reports, you have to look at the data that you have and figure out if you need additional tabs to line stuff up, nicely. And you can see there's a lot of variation normally in customer names in terms of length. So you have to figure out what's the longest name I'm going to store and then use enough tabs to line stuff up. So I've got a slightly longer name here, so I would need an extra tab to go over to the major to get the majors to line up nicely. GPAs, Pat sees in some trouble, obviously, and of course when formatting a table like this, we would want to round numbers to some fixed number of decimal places. Otherwise, it's really tough to line stuff up, in this sort of basic report generation technique. I hope it all seems kind of obvious, but I know that lots of the little individual bits of syntax can be confusing when you're typing it in on your own. Hopefully it doesn't seem as confusing when I'm doing it and describing it. But I know if you're sitting on your own trying to do it and trying to remember, wait, what was the syntax to create that array? I know it's weird, and then to remember, well, wait a minute, just creating that array on line 4 creates an empty array. There's nothing in it. I have to put the data in it. So if I skip this step, then I'll have an empty array, and the for loop's going to die right here when it tries to access the first data element because there's nothing in it. I think you could all take it the next step. I think you all know how to round to 2 decimal places. You can use the so-called quote-unquote bad money round technique if you want to, because GPA is not a currency, so we don't have to worry about how we round it necessarily. And if your GPA is something like 3.2, it's perfectly fine to display it as 3.2 and not 3.20. So the bad money round is a perfectly good way to round doubles like that aren't currency. So I'm going to switch back to the presentation. Okay, so you should see me, scary Sith me, and pizza point of sale. So this is our first point of sale. And if you're reading ahead in the book, you'll know it's the first of a number to come in a series that look at different aspects of coding in Java with this common thread of how would we create a point of sale for this pirate pizzeria restaurant. So at first, this is about as simple as it can be. And so all the goal is for this is to allow the sales clerk at the Pirate Pizzeria to add pizzas to a customer's order. And then when you're done, place the order, hitting the place order button. So there's just an add pizza button and there's a place order button. In this initial example, the pizzas are entirely random. So they're given a random size, a random style, deep dish, thin, and so on, a random number of toppings, and then a price. And the price is actually based on a little calculation so that it makes sense. So it looks at the size, It looks at the style, so deep dish is more expensive than thin. And it looks at the number of toppings and adds, more cost if there's more number of toppings. So you should look across it and see some sort of commonality, so that the biggest pizzas and the deep dish one there at the top actually is close to the most expensive. If it had 3 toppings, it'd be even more expensive. But and $26 is a lot of money for a pizza, and you might be tempted to think it's a really good pizza, but again, the restaurant's awful and the pizzas are not great. So $26 is a complete ripoff. But what we want to do to build this up is think about it in an object-oriented manner. What do we need in terms of objects to create a report like this? Well, what you're seeing now isn't pirate customers, but it's pizzas. So we need a class to describe pizza objects. And so as you start thinking about it, you think, so, okay, well then what are the attributes? Well, there's the size, there's the crust style, and there's toppings, and there's a price. So, right off the bat, you can kind of in your head see, okay, I'm going to need probably these 4 attributes, maybe others that I'm not thinking of, but these make sense. The real question becomes, what do I need to do with pizzas? And so in this report, you can see all you really need to do is describe them for the text area. And then we also, what you don't see is when you press the order pizza or place order button, it will pop up a little dialog that says, thanks for ordering, your total is whatever. So we need to add together, we need to be able to calculate the total for the order. It is pretty simple. The point of sale will get more complex as we grow it to become somewhat more realistic, more and more realistic. And this is this slide is an example here of some of the things that we're going to think through and add. But the key is, it's also kind of like building a database for this pizzeria. You would want to think through, what are the things that are going on in this business scenario that I'm going to need to be able to capture and represent and store and then work with to create the functionality that I need. And so we will get to the point where, for instance, we're going to add other types of food, and we're going to learn a technique where it makes sense to describe what all the foods have in common and to code that class first. We're going to call it eventually food item. And then pizzas will be an example of, or a subclass of, food item, as will beverages and desserts. There'll be, and any other foods that we sold would be subclasses of this superclass food item. We don't have that skill yet. We're gonna get it in chapter 11. So it is on the way, but we're not there yet. And this particular point of sale doesn't require, we're only selling pizzas, so it's fine to start out with just a class that describes pizzas. And like I said, there's 4 attributes probably that you can think of just by looking at the screenshot of the report. There's the size, the crust style, the toppings, and the price. That's kind of the easy step. The somewhat harder step is, well, what are the data types? Right, should size be a string, like large? Or should it be like a numeric code of some sort that represents the size, like an integer? Same thing with crust style. Should it be a string like deep dish, or should it be an integer code that represents a crust style? Toppings, at what point do I want to be able to list out the different types of toppings, like pepperoni, sausage, mushroom, so on, or some sort of code number for each topping? How should that work? And then price. We haven't gotten to our chapter 15 yet on really handling money the right way, but right off the bat, you want to ask, well, should it be a double? Even though I know doubles have decimal places that don't make sense in money, they can be rounded to 2 decimal places, and not using bad money round. We know how to use number format to get us a price that looks right. So is double good enough for that? And at this point, yeah, it is. These are design questions. They're questions that you have to answer for yourself in terms of how do I want to code this? Or if it's a team project, obviously how does the team want to code it? The way I've coded this initial example is I've used integer codes for size and crust style. And toppings is just a very simplified count, so it's a counter, so it's also an integer. And then I'll put price as a double. Then you need to think through the methods. Well, there aren't that many methods. We need a method to calculate the price, so it needs to do that little bit of math that figures out, based on the size and the crust style and the number of toppings, what's a reasonable price to charge, what's the correct price to charge for that. It'd be handy to have a method that generates a text description of each pizza, so builds up that string so that when we need a description of the pizza, we can just we can ask the pizza itself for that description. That's a kind of a next step in sophistication that will put us in good stead as we add complexity to the point of sale later. And we probably need getters and setters. I mean, we need to ask ourselves, do we want to make, do we want to give direct access to our attributes to make them public or package level access, or to make pizza an inner class? Or do we want to add a little bit more, security to it so that we don't allow direct access, and instead we intermediate between the programmer and the attributes using getters and setters, in which we can put data validation code or default settings or whatever makes a little bit more sense. So what I've got is a description of why I picked the integers for the attributes. There are advantages to each approach, and obviously in terms of building up string descriptions of the pizza, we want those text values, small, medium, large, thin crust, thick crust, whatever. We don't want integer codes, but we like the idea of integer codes in terms of they'll be useful in terms of generating the price. If we wanted to create a formula based on the size, it would be easier if we could, multiply a number by a number, because you can't multiply a string by a number. So there's advantages to both approaches. Frequently working with strings is a bit more of a challenge for most beginning programmers, so I avoid that entirely just by working with integers. And then when I need a text description of the pizza, I can get that easily. I can write the method to do that fairly easily, and I'll show you different ways to write that. So I'll use two get methods that will take the integer values of the pizza, both its size and its crust style, and turn it into two descriptive strings. And I'll use different techniques to do each one of the gets so that you see alternate ways to do it. Hopefully one or both will click with you and seem fairly easy. Toppings are slightly more difficult. Again, we could just count the toppings, but it also could be something where maybe it makes more sense to have an array that describes different types of toppings, and then we can add those toppings specifically to a pizza. That might be a nice step forward in terms of complexity. The price itself, like I said, is just a calculation. So if size and crust are the name of those attributes that describe the size and the crust, a basic pizza price calculation, this is slightly more complex because I've added an overhead rate, essentially a shop charge to start everything out, and then I add on a size and a crust multiplier, and then I add on just a fixed fee for however many toppings I have. We will in the future make this more sophisticated, and we'll charge, say, more for mushrooms and less for onions or whatever the case may be, just based on how expensive individual toppings are. But at this point, I'm trying to keep it fairly simple, and I'm just multiplying by the number of toppings. And then the constructor, this is not going to be an example probably where we're going to want to initialize the values for the pizza to some starting point, because there's no such thing as a default, pizza. So we're going to need a constructor that allows the programmer to set these aspects of the pizza. What size is it? What crust style is it? And what are the toppings? So that will require us to create a detailed constructor which initializes those three values. We don't have to pass it a price because the pizza can calculate its own price based on what type of pizza it is, what the value of those attributes are. And so here's the next simplification, essentially. In a real point of sale, obviously, when you hit add pizza, you might get a dialog that popped up that said, okay, what kind of pizza? What size is it? What's the crust style? And then, here, add whatever toppings you want. That would make the app way more complex, which is not what we're really talking about in this chapter. We're talking about how to create this pizza class and use it. So instead, the pizzas will be random. When you press the Add Pizza button, it will create a new pizza with a random size. a random crust style, and some random toppings. And this is the second thing that makes these integer values for these attributes slightly better fit to this, because now I can generate a random size by generating a random integer number between, say, 0 and 3. And that will correspond to small, medium, large, extra large, or whatever we end up calling it. If these attributes were strings, we could still do this. It just makes it a little bit more involved to create random objects of that type. Of course, this is all based on a simplification that is trying to focus us just on what the pizza is going to be like and how we use it, not necessarily trying to be as realistic as possible. So the UML is the last thing I want to look at here. If we follow these decisions, these choices, then the UML that we're going to create will look something like this. So pizza is a class, capital P. It has 4 attributes. You can see them in the UML. They are the integer size, the integer crust, an array of strings called toppings, and a double price attribute. As with all the other classes, I'm making those default or package level access for the time being. The methods are a constructor method, a getPrice method, which calculates the price and returns it as a double, a getSizeAsString method, which takes the integer size and returns it as a descriptive size, like small, medium, large, extra large. Same thing with crust style. getCrustStyleAsString uses or interprets kind of the crust style integer in the form of text, like hand-tossed or thin or thick or whatever the case may be. And then the method that will describe each pizza as text for use in our UI is called toString. And you might wonder why I didn't call it something like getPizzaAsString or something that would follow my other get methods more consistently. And it'd be a great question. It does kind of stick out as a weird method naming choice. But it's done intentionally. toString is a default method in Java that performs this task. So lots of classes in Java that are built in provide a toString method which describes the object as text. And so there are places in Java where it expects to be able to call the toString method and use its output in ways that are useful. So if I name this method toString, it will help out when I use certain UI elements in Java because they will expect to be able to find toString and call it and use it. So if I call it something else, it won't work. If I call it toString, it'll make certain things much easier down the road. Not really today or next time, but down the road a little farther. All right. This is where I wanted to get to today, which is just to show you the initial UI, what it looks like, and then think through what do we need the pizza class to look like to be able to write an app like this. And we've thought through all of that in detail, and we will implement it next time. Obviously, the app is in the download for the chapter. You can look at it, you can play with it. It is very simple. It's based on a series of simplifications that allow us to create a fairly straightforward class and get a pizzeria point of sale working. And also to make the code easier to write and easier to read and work with. So I hope when we get to the actual code, this all makes pretty good sense. But this is where I wanted to get to. That is today's material. I wish you all a very nice afternoon and Halloween, obviously. I hope nobody gets a bag of grapes or a handful of miscellaneous Flintstones because those would be gross.